You know that iconic image of Mount Everest? You know the one I'm talking about, right? With that massive plume of snow trailing off the peak. It's almost like the mountain is waving a giant flag.
Pretty amazing sight. Well, we are going to unpack the science behind that breathtaking scene today.
And it's more than just a pretty picture. It's a window into all those powerful forces that are at play in the Himalayas. You know, everything from weather patterns to the potential impact of climate change.
Exactly. And the source material for this deep dive is a research paper from 2004. It's called Mount Everest Snow Plume, a case study. And it was published in Geophysical Research Letters. It all starts with this photograph taken from space, and I've got to say it is absolutely stunning.
Yeah, it's a remarkable image. Astronauts aboard the International Space Station, they captured this shot on January 28th, 2004, looking south towards Everest, and it shows this enormous snow plume extending eastward from the summit. They estimated it to be 15 to 20 kilometers long, and anywhere from 500 meters to a full kilometer deep. Wow, that's longer than Manhattan.
That's incredible.
Huh.
Can you set the scene for us a little more? What else can we see in this photo?
Okay, so picture this. Tibet in the foreground, with all of its rugged terrain, and then off in the distance, you've got Nepal, shrouded in clouds, in the background. The snow plume really stands out starkly against this backdrop, almost like a white arrow just pointing eastward. And you can actually see another shorter plume extending from Makalu, the fifth highest mountain in the world, which really gives you a sense of scale.
So we've got this massive plume stretching for kilometers. What does it actually take to create something like that? Is it just a really strong gust of wind?
Well, it's definitely more than just a gust of wind. It's a fascinating interplay of several factors. First, we have to consider the East Asian jet stream, this powerful air current that flows high above the Himalayas. And on the day this photo was taken, the jet stream was not only unusually strong, but it had also shifted southward, right over Everest. Okay, so imagine this river of wind, high in the atmosphere, flowing right over the peak of Mount Everest. What kind of wind speeds are we talking about here?
So researchers estimated the wind speeds near Everest's summit to be around 50 meters per second. And to put that into perspective, that's significantly stronger than the average wind speed at that altitude for that time of year. So we're talking hurricane force winds.
Hurricane force winds. Okay, so we've got powerful winds, but that can't be the whole story, right? I mean, there has to be something for the wind to pick up to create this plume, something for it to grab onto.
You're absolutely right. And that brings us to the second crucial ingredient, a major snowfall event that blanketed the Himalayas just days before this photo was snapped.
Yeah.
Data from the TRMM multi-satellite precipitation analysis showed heavy precipitation from January 22nd to 25th. It dumped 30 to 50 millimeters of water equivalent on the Everest region.
That's a lot of snow. So you've got all this fresh snow sitting on the mountain, and then these hurricane force winds come roaring in. It's like the perfect recipe for a snow plume, right?
Precisely. The combination of heavy, fresh snowfall and exceptionally strong winds is what created the dramatic plume we see in this image. All that fresh, unconsolidated snow was easily lifted and carried away by the jet stream.
But how can scientists be sure this is a snow plume and not just a cloud formation? I know there are certain types of clouds that are associated with mountains. How can we tell the difference?
That's a great question. You're likely thinking of banner clouds, which can sometimes resemble snow plumes. However, there are a few key clues that tell us this is indeed a plume of wind-blown snow. First, the timing. It was observed right after a major snowfall event, which provided the source material for the plume. Second, there were no other clouds in the region at the time, and the temperatures near Everest's summit were extremely cold, making cloud formation unlikely.
Okay, so the timing and the overall conditions seem to rule out clouds. What else points to this being a true snow plume?
Well, the plume's exceptional length, 15 to 20 kilometers, is another strong indicator. Banner clouds, they tend to be much shorter, and they usually form on the leeward side of mountains. Plus, banner clouds are more common during warmer seasons, while this event happened in January. All of the evidence points to this being a true snow plume caused by the powerful interaction of wind and snow.
It's amazing how scientists can piece together all of these clues, from the timing to the weather conditions to the plume shape, to figure out exactly what's going on. But how do they actually measure something like this? I mean, it's not like they can just climb up there with a ruler, right?
You're absolutely right. They can't just climb up there with a ruler. In this case, they used a mathematical model to estimate the plume's depth, taking into account the wind speed, the plume's length in the photograph, and the fall speed of snow.
That's fascinating. A simple model, but it gets the job done. And did the model's estimations match up with what they observed in the photo?
Yes, it did. The model estimated a depth of 300 to 600 meters, which aligns perfectly with what we see in the ISS photo. But what's even more intriguing is that this model also suggests that given the extreme wind speeds possible near Everest's summit, plumes could potentially stretch even further, over 30 kilometers long.
Okay, so even longer than the one in the photo. That's almost unfathomable. But is this just a visual spectacle, or does it actually have implications for the environment up there?
Oh, it's definitely more than just a visual spectacle. These plumes play a crucial role in how snow is redistributed across the Himalayas. And that, in turn, has significant implications for glacier mass balance and even avalanche risk.
Now things are getting really interesting. So we're not just talking about a cool visual phenomenon here. We're talking about something that can have real-world consequences for this fragile environment.
Exactly. And we haven't even touched on the potential impact of climate change on this system, which is a whole other layer of complexity. But we'll dive deeper into that in just a moment.
All right, I'm ready to dive deeper. Stay with us as we continue exploring the fascinating world of Mount Everest's snow plumes. So we've been talking about this incredible interplay of wind and snow high atop Mount Everest, but I'm curious, how do scientists actually study these snow plumes in more detail?
Well, it's not like they can just set up a weather station on Everest's summit.
Yeah.
It's an incredibly challenging environment to work in.
Yeah, that's for sure. So how do they gather data?
Well, they've gotten pretty creative. They use a combination of remote sensing techniques and modeling. Satellites, for instance, can track the movement and evolution of these plumes over time.
So we can actually watch these plumes form and dissipate from space.
Exactly. And that gives researchers valuable information about their size, their speed, and even their composition.
I imagine that data must be helpful for understanding how snow is redistributed across the Himalayas.
Absolutely. And that ties into our earlier conversation about glacier mass balance. Glaciers rely on a balance of snowfall accumulation and melt, and these plumes can actually influence both of those processes.
Okay, so let's break that down. How can a snow plume affect a glacier?
Well, if a plume carries snow away from a glacier, it can contribute to a decrease in its overall mass. On the other hand, if a plume deposits snow onto a glacier, it can help to build up its mass.
So it's like this delicate balancing act.
Exactly. And the direction and intensity of the wind, as well as the amount of snowfall, all play a role in determining where that snow ends up.
And this is all happening in a region that's already being impacted by climate change, right? We were talking about the potential for more intense jet stream activity and heavier snowfall events.
Precisely. And those changes could have a significant impact on the frequency and intensity of these snow plumes, which could then further disrupt the delicate balance of Himalayan glaciers.
So we're essentially talking about a chain reaction here, right? Climate change alters weather patterns, which in turn affect these snow plumes, which then have consequences for glacier health and even avalanche risk.
You got it. It's a reminder that everything in our environment is interconnected. Even something as seemingly isolated as a snow plume on Mount Everest can be linked to global climate patterns.
It makes you realize just how complex and fragile our planet is. But I'm curious, if climate change continues to alter jet stream patterns and potentially increase snowfall in the Himalayas, what does that mean for the future of these snow plumes?
That's a question that scientists are still trying to answer. Some models suggest that we might see more frequent and intense snow plumes in the future, while others suggest they might actually decrease in frequency.
Why would they decrease if there's potentially more snow available?
Well, it comes down to the complex interplay of various factors. Yeah. Even if there's more snowfall, changes in wind patterns and temperatures could affect the formation and behavior of these plumes in unpredictable ways.
So it's not a simple equation of more snow equals more plumes?
Not at all. It's a dynamic system with lots of variables. That's why continued research and monitoring are so crucial. We need to gather more data to better understand how these plumes might evolve in a changing climate.
This all makes me think about that 2004 research paper we mentioned earlier. It really highlights the need for long-term studies to track these changes over time.
Absolutely. We need to be able to compare data from different years and decades to identify trends and patterns. That's how we can start to piece together the bigger picture of what's happening in the Himalayas.
And I imagine advancements in technology are helping with that, right? Things like higher resolution satellite imagery and more sophisticated computer models.
Definitely. We have so many more tools at our disposal now than we did even a decade ago. And those tools are allowing us to delve deeper into the mysteries of these snow plumes than ever before.
It's amazing to think that a single photograph from space sparked such a deep dive into Himalayan meteorology. It really shows the power of observation and scientific curiosity.
It really does. And it underscores the fact that there's still so much we don't know about our planet. Each new discovery opens up new avenues of exploration and raises new questions.
Which is what makes science so fascinating. It's a never-ending journey of discovery.
Exactly. And who knows what other secrets are hidden in those breathtaking views of Mount Everest? Perhaps our listeners will be the ones to uncover them.
That's a great thought. Maybe one of our listeners will become the next great Himalayan researcher, inspired by this very conversation. Speaking of inspiration, there's one more aspect of this topic I want to touch on before we wrap things up. So we've been talking about the science behind these snow plumes, all the data and the models, but I want to shift gears for a moment and talk about the human element.
What do you mean by that?
Well, we've mentioned climbers and local communities, of course, but I'm thinking more broadly, about our relationship with mountains, especially these iconic ones like Everest.
Ah, I see what you're getting at.
Yeah.
There's a certain mystique surrounding mountains, isn't there? A sense of awe and wonder that draws people to them.
Exactly. And these snow plumes, they kind of add another layer to that mystique, don't they? They're like a visual reminder of the power and unpredictability of nature.
Absolutely. They show us that even something as massive and seemingly permanent as Mount Everest is constantly changing, shaped by forces beyond our control.
It's humbling, isn't it? It makes you really appreciate the delicate balance of the natural world.
It certainly does. And it underscores the importance of respecting and protecting these fragile environments.
It's interesting to think about how our understanding of these plumes has evolved over time. We started with that single photograph from the International Space Station, and now we have all these sophisticated tools and models to study them.
It's a testament to human ingenuity and our insatiable curiosity about the world around us.
And it makes me wonder what other discoveries are waiting to be made out there. What other secrets are hidden in those breathtaking views of Mount Everest?
Who knows? Perhaps one of our listeners will be the one to unlock those secrets. Maybe they'll be inspired by this very conversation to pursue a career in science or exploration.
That would be incredible. And speaking of inspiration, I think this whole deep dive has been a great reminder that even something as seemingly simple as a plume of snow can teach us so much about our planet.
It really has. We've learned about weather patterns, climate change, glacier dynamics, and even the human relationship with nature.
And it all started with a single question. What's that white streak trailing off Mount Everest?
It's amazing how one simple question can lead to so many fascinating insights.
Well, that's the beauty of science, isn't it? It's all about asking questions and seeking answers, no matter how big or small.
And it's a journey that never truly ends. There's always more to learn, more to discover.
Well said. And on that note, I think it's time for us to wrap up this deep dive into the world of Mount Everest's snow plumes.
Thanks for joining us on this journey. We hope you've enjoyed exploring these fascinating phenomena with us.
We sure have. And we hope you'll join us next time for another deep dive into the wonders of our natural world.
Until then, keep looking up, keep asking questions, and keep exploring.